Pydantic AI agents accept capabilities that hook into the agent lifecycle, and AbstractCapability is the base class that lets you intercept and modify how an agent runs. A capability like max model requests demonstrates this by counting model requests and ending the run early once a threshold is hit. You are about to see a custom capability that overrides for_run to isolate per run state and wrap_node run to intercept ModelRequestNode executions, returning an end result with a final result when the limit is exceeded. From data classes, import data class. From typing, import any. From Pydantic graph, import end. From Pydantic AI, import ModelRequestNode. Run context. From Pydantic AI, capabilities, import AbstractCapability, agent node, node result, wrap node run handler. From Pydantic AI, result, import final result. At data class, class max model requests AbstractCapability any. It limits the number of model requests per run by ending early. Max requests, int equals 5. Count, int equals 0. Async def for run self, CTX, run context any, max model requests. Return max model requests max, requests equals self. Max requests hash fresh per run. Async def wrap node run. Self CTX, run context any asterisk node, agent node any handler, wrap node run handler any. Node result any. If isinstance a node, ModelRequestNode. Self.count plus equals 1. If self.count, self max requests. Return end final result output equals max model requests reached. Return await handle a node. This is a request limiting capability that intercepts graph nodes via wrap node run to count ModelRequestNode executions and short circuit after a threshold. When the count exceeds max requests, it returns an end result instead of delegating to the handler, terminating the run early with a final output. The for_run hook returns a fresh instance per run so the counter doesn't leak between separate agent runs. The wrap node run pattern gives middleware-style control over each graph node transition. Here it's used as a guard clause that inspects node type before deciding whether to proceed. This is the same mechanism the node logging example uses for observation, but here it modifies graph progression by returning end instead of calling handler. The trade-off is that state isolation via for_run means you can't track total requests across runs without a separate shared counter. But that's usually the right call to avoid state pollution between independent invocations. Let's break it down line by line. From data classes, import data class. Imports data class from Python's standard library data classes, module for creating classes that auto-generate init, repr, and other dunder methods via the @dataclass decorator. From typing, import any. Imports any from the typing module for runtime type flexibility. From Pydantic graph, import end. Imports end from the Pydantic graph module for use in the current codebase. From Pydantic AI, import ModelRequestNode. Run context. Imports ModelRequestNode and run context from Pydantic AI for type annotations and runtime context access in agent runs. From Pydantic AI, capabilities, import AbstractCapability, agent node, node result, wrap node run handler. Imports AbstractCapability, agent node, node result, and wrap node run handler from Pydantic AI. Capabilities for use in agent capability and node handling. From Pydantic AI, result, import final result. Imports final result from Pydantic AI, result for accessing the final result of an agent run. At data class, class max model requests AbstractCapability any. It limits the number of model requests per run by ending early.
Defines a data class named maxModelRequests that subclasses AbstractCapability. With a docstring stating, it limits model requests per run by ending early.
Max requests, int equals 5.
Defines max requests as an integer set to 5.
Count, int equals 0.
Declares an integer variable named count, initialized to 0.
Async def for run self, CTX, run context any, max model requests.
Defines an async method, for run, on a class that accepts a run context parameter and returns a max model requests value.
Return max model requests max requests equals self. Max requests hash fresh per run.
Returns a new max model requests object initialized with the instance's max requests value, creating a fresh limit object for each run.
Async def wrap node run.
Defines an async function named wrap_node_run. No parameters or body visible in this segment.
Self CTX, run context any asterisk node, agent node any handler, wrap node run handler any.
Defines a lifecycle hook method signature that receives the current run context, the agent node being executed, and a handler function as keyword-only parameters, used to wrap node execution in a capability.
If isinstance a node, ModelRequestNode.
Checks whether node is an instance of ModelRequestNode, branching code based on that type.
Self.count plus equals 1.
Increments the instance's count attribute by 1.
If self.count, self-max requests.
Checks whether the instance's request count exceeds its maximum allowed requests.
Return end final result output equals max model requests reached.
Returns an end object containing a final result with the message max model requests reached, signaling the agent run terminates with this result.
Return await handler node.
Awaits the result of calling handler with node as argument and returns it. So the whole thing ties together around one idea. Capabilities give you middleware-style hooks into the agent lifecycle, and max model requests uses 2 of them to enforce a request ceiling. The for-run hook hands out a fresh counter each time the agent runs, so isolated invocations don't stomp on each other's state. Then wrap_node_run intercepts every node execution, checks if it's a model request node, bumps the counter, and either returns an end with a final result when the threshold is crossed or delegates to the handler to keep the graph moving. The trade-off is that this per-run isolation means you can't accumulate a total count across runs without a separate shared mechanism. But that's the deliberate choice to avoid state leaking between independent agent invocations.
The handler that never runs watches count exceed 5. Returns end. Model never speaks. Run